Right, hello everyone and welcome to this talk, Antipatterns and Observability, Lessons Learned and How OpenTelemetry Helps You Solve Them. I'm super excited to be here at KubeCon Hong Kong. Love talking about these two topics, observability and OpenTelemetry, but when it really comes to like pitfalls and anti-patterns and environments, I don't think it's something that's talked about enough. It's more about the technology and how to leverage it, but if you don't leverage it correctly, you can actually run into issues, and that's what I'd like to talk about today. First, a quick introduction. My name is Steve Flanders. I've been part of the OpenTelemetry project since the very beginning. I've been in the monitoring and observability space for over a decade, working on logs, metrics, and tracing distributed systems for observability platforms. I'm also the author of a book called Mastering OpenTelemetry and Observability, and I hope you'll take a look at it. All right, so before we get started, I want to define the terminology that's being used here just to make sure that we're all on the same page, and then we'll get into some examples of what they all mean. The first is, well, what is an anti-pattern? An anti-pattern is basically a behavior that if you do it, will have consequences. They could be consequences now, they could be consequences in the future, but they basically don't help you realize or be as efficient as you could possibly be. Now, we're going to be talking about anti-patterns in the context of observability. And so when you have an anti-pattern in observability, it basically means that you will not be able to successfully implement it or fully utilize it because of the pattern or behavior that's being leveraged. Now, the next term is observability, and many people have different definitions for this. I like to refer to it as being able to answer unknown unknowns in your environment. What do I mean? Maybe you've experienced a problem for the first time. You've never seen it before. Well, if you're collecting the right amount of telemetry data and you have the right observability platform, you should be able to answer any question using the platform and the data that you have to solve that. This could be problem isolation, root cause analysis, remediation, but you basically have everything necessary to do it in your observability platform. And then finally, OpenTelemetry. How many people have heard of OpenTelemetry? Show of hands. All right. How many people are using OpenTelemetry in production? Show of hands. Pretty good, about half the room in comparison. So this is great, I think, right? OpenTelemetry is a great CNCF project. It is actually an open standard for generating, collecting, and processing telemetry data. OpenTelemetry refers to these as signals. So traces, metrics, and logs are referred to as signals. But it's basically made up of three primary components. The open standard is called the specification. This is the definition that can be used, and it supports other open standards as well. And then on top of the specification, there are two reference implementations. Instrumentation libraries. This is a language-specific way to generate telemetry data. Every major language you can think of is supported: Java, PHP, Ruby, Rust, Erlang. And then you have data collection, which is a way of receiving, processing, and exporting telemetry data. This is primarily done through the OpenTelemetry collector, but there are a ton of other integrations and options available as well, including things like Apache Arrow. We'll dig more into these in just a little bit. All right, so with the terminology out of the way, how about a few just relatable examples of anti-patterns that are more general, maybe not fully applicable to observability or even OpenTelemetry? So anyone ever heard the saying before, we've always done it this way, like at your company? Like people are just like, we've always had it this way. Well, that's an anti-pattern, because over time, things change. And if you're not evolving or adapting to these changes, you're going to fall behind the curve, right? So maybe you've always done it without AI, but like AI is very popular these days, and if you're not picking it up, you're going to eventually fall behind. So you can't keep doing that. You should stay up on the latest trends. Another example for the software developers in the room, it works on my machine. Well, just because it works locally doesn't mean it's going to work in production. That's another anti-pattern. Do you have the same environment? Are they configured the same? If it's not the same, then it doesn't really matter that it works locally on your machine. Another one, just ship it, or testing fully in production. This is when you have code and it works locally and you decide to deploy it out, but you haven't thought about all the operational aspects that actually matter as well. Like, do you have runbooks? Have you added observability so you can actually make sure you can monitor the health and performance of your system? And do you have the right testing in place? For example, you might have functional and integration testing. That's great, but if you don't also have end-to-end testing, it may not work properly in the environment. That's going to cause problems for you. Another example would be, we'll fix that later. This can be okay at times. For example, if you're building a new service, you may not have to solve for massive scale immediately, but as the customer demand grows, you're going to have to find a way to scale that platform or service that you've built. But if you're constantly saying, we'll just deal with that later, you're actually accumulating a lot of technical debt. And eventually, you'll have to pay down that debt, and it will slow you down. And it may even stop all feature development. So eventually, you have to get in front of this, otherwise it's another anti-pattern. More generic things, on the management side, if you've ever heard everything is a priority, you have to stop the world and be reactive. Maybe it's a customer escalation, maybe it's a business need. If everything is a priority, then nothing is a priority, and that means you're not doing anything really, really well. You're doing a little bit of everything. Pretending to agree, another management one, where you think you have consensus. Everyone generally says, yes, they agree with the strategy or the direction that you're going in. But what you find out is they don't actually agree, and they're actually pushing back against this and making it harder to actually achieve the goals that you set forward. Invisible work. Maybe you have a plan for a quarter or for a year. You've defined OKRs, objectives and key results, or KPIs, key performance indicators. But people then take on additional work that's not being tracked. This invisible work can actually impact the outcomes that you're trying to deliver. So it's important that you actually track that work. More metrics means more clarity. Well, only if you're monitoring the right things. Otherwise, you just have a whole bunch of data and you don't necessarily know what it means or whether it's valuable. Measuring what's easy, not what matters. This is pretty common, do what's easy versus doing what's hard. But doing what's hard is usually what's necessary to be successful. Meetings that should have been emails, my own personal pet peeve as a manager, right? This one kills me. It wastes a lot of time, especially if you have a lot of people in there, whether it's managers or engineers or product managers or what have you. It doesn't make you very efficient. Urgency over strategy. Also another anti-pattern. The list goes on and on. I could spend an entire day just kind of on this slide. But here's the major takeaway. If you don't recognize and address these anti-patterns, then the net result is that you normalize dysfunction. And that has consequences. What are these consequences? They are things like wasted effort, poor collaboration, degraded performance, and of course, solutions that solve the wrong problems. And that's what we're going to talk about in the context of observability throughout the rest of this talk. All right, now I'm going to do this on 3 unique categories. So we're going to start with telemetry data, and then we're going to talk about 2 more. For each of these categories, I'm going to try to give you 2 or 3 examples of what I'm referring to as an anti-pattern and how things like OpenTelemetry can actually help you with them. We'll spend the most of the time here in the telemetry data section because I think as a more technical audience, people kind of appreciate the technical details more than the management aspects, but I will cover all 3. So first anti-pattern for telemetry data, incomplete instrumentation. What do I mean? Well, you have a bunch of services in your environment. Maybe you have some amount of traces, metrics, logs, profiles, sessions. Pick your telemetry source in there. But you don't have enough. You don't have complete instrumentation. So why does this impact you? Well, you can't actually alert or analyze on data that you do not have. So if you haven't instrumented properly, you're going to have gaps or holes in your observability, and thus it's going to be much harder to do problem isolation or remediation. I've seen this a few different ways. For example, maybe you have multiple services that are owned by different service owners, and some service owner teams are good at instrumenting while others are not. And so depending on the service you're looking at, the instrumentation is better or worse. I've seen this for within the service itself, function level calls are very well instrumented, but external calls to network devices or maybe third-party services are not instrumented. This is problematic because maybe that downstream service is the one that's causing you problems. Now, here is where OpenTelemetry can really help. OpenTelemetry provides instrumentation libraries, as I mentioned, and it basically has 3 different ways of instrumenting. You can do what's called manual instrumentation. That is, you add the instrumentation to the code yourself. So you'd have to do this for every single language and every single service that you care about. It also has something called zero config instrumentation, also referred to as automatic instrumentation. This can inject instrumentation at runtime, making it much easier to get started. And then there's kind of framework instrumentation, which is still manual, but you take a dependency on a library or framework that's already instrumented, and once that dependency is added, you kind of get that service instrumentation for free. Now, zero config instrumentation is a great way to make sure that you don't have incomplete instrumentation, because the OpenTelemetry project is trying to make sure that all the libraries and frameworks that it supports actually provide good instrumentation out of the box for you. You don't have to go read all the documentation or kind of figure it out. You can just add a couple runtime parameters to your service, and you will get instrumentation. So let me give you an example with Java. Let's say that you have a jar file that you are running, and you want to add zero config instrumentation to it using OpenTelemetry. Well, you see two examples here. One, you can add runtime parameters, passing the Java agent flag and the OpenTelemetry Java agent jar. And then you have to specify a service name. This is just a parameter to identify the service that you're running in. You don't technically have to specify it because it has a default value, but if all your services are called Java, that's not going to be very useful. So you're probably going to want to set this parameter at the very least. And there's a variety of different ways to set this. You can see it through the CLI, but you can also do it through environmental variables and other means as well. With this simple change, you will get instrumentation in your Java application for a wide range of libraries and frameworks, and this is similar for other languages as well. Now, let's again explain why incomplete instrumentation matters. Here's an architectural diagram for an e-commerce application. The way to read this is that every rectangle represents a service in your environment. And let's say it's a polyglot environment, meaning that every single service is written in a different language. Now, what might a transaction look like, a user interaction with this service? Well, let's say I'm on this service and I want to check out. I have a cart full of items and I'm going to hit the checkout button so that I can purchase the items that I have in my cart. How might that look? Well, you'd have to call the front end. The front end's going to call the checkout service. The checkout service needs to check the cart service, which then needs to call the payment service, the currency service, the shipping service, and the email service. So one button, basically checking out, is going to call a whole bunch of downstream services. This is transparent to me as the end user, but as a service owner, I need to understand how this architecture and service flows. Well, this transaction could be represented as a distributed trace, or as a trace. And a trace can be represented in a waterfall view. So for example, here's an example from Jaeger, another CNCF project that supports distributed tracing. You can again see the front end, checkout, cart, currency, shipping, payment. You can also see the duration of each of those operations for the calls that are being made. And if there were errors, they would actually be highlighted here as well. Now, going back to the incomplete instrumentation example, let's say the checkout service there is not instrumented and everything else is. What would happen? You would actually have a disconnected trace. You would see a trace with a single span for the front end. You would see another trace with a single span for the cart service. You'd see a single trace with two spans for the currency service. Everything would be disconnected. Well, why does this matter? Well, now it's harder to do problem isolation and root cause analysis because I don't have the full context. Everything is broken up. That's one of the downfalls of distributed tracing. And to be fair, it's not an individual trace that really matters as much as the aggregate data. So for example, as I see over time the interactions with my service, I can actually represent that visually in the observability platform that I'm using. So here's an example of taking just distributed tracing data and being able to basically reconstruct that architectural diagram that you saw on the first slide in an observability platform. And here, the services are circle. The size of the circle tells you how many requests it's receiving. So the larger the circle, the more requests. And you can even see things like red metrics, requests, errors, and duration highlighted on this. So for example, the currency service and the place orders message queue both have errors. And you can see some high latency going to the checkout service and a few other services in this diagram. Now, if you want to actually drill in and actually understand why, for example, is the currency service experiencing errors, you could actually break that down by the metadata that's in your telemetry data, telling you like what host it's running on, Kubernetes, pod, maybe your EC2 instance, what environment it's running on, what service version it has. And it's actually this metadata breakdown that'll help you pinpoint where the problem is occurring, isolating it, and getting you to remediation. All of this is possible, but only if you have enough instrumentation. Now, on the flip side of incomplete instrumentation, another anti-pattern is over-instrumentation. This is when you instrument absolutely everything, but it doesn't necessarily provide value. Now, why would over-instrumentation be a problem? Well, if it doesn't provide a value, it's like trying to find a needle in the haystack. I now have a bunch of data that I have to kind of sift through. What is important, what isn't, why am I collecting that? But there are some other reasons why, too. For example, there's a cost associated with adding instrumentation to your app. It's not free. It's going to take some amount of CPU cycles and memory utilization. And the more instrumentation you add, the more compute and resources it's going to require. That means you might have to scale up your service, for example, or scale it out in order to support your instrumentation needs. This also happens on the observability platform backend side. You're going to have to pay for all that additional telemetry data that you're collecting. Is it valuable? If not, then why are you paying a large amount of money for it? This can even impact the performance of the observability platform. Maybe the UI slows down, or issuing queries takes a long time to resolve. That's a net result of too much data. So what you really want to have is a balance. You need to be able to see end-to-end flows and connections inbound and outbound of your service, but you don't need like every last line instrumented to the point where you're just generating a ton of data that doesn't actually tell you where problems occur. You want to find error-prone areas, and you want to find especially external calls that are going to cause you problems. Now, OpenTelemetry automatic instrumentation may, in some cases, actually over-instrument for you. What do I mean by that? Well, as I mentioned, the auto-instrumentation is actually trying to instrument the libraries and frameworks and provide you with some amount of telemetry data that is likely going to be useful, but every environment is different. And maybe in your environment, the telemetry data that's being generated doesn't actually tell you about problems that you care about. So you'll probably want to configure it to some extent. Luckily, OpenTelemetry is very customizable. Even the automatic instrumentation supports a wide range of configuration parameters, allowing you to toggle on or off instrumentation and even get very granular with it, whether you want to get down to function calls or not. Beyond this, the OpenTelemetry collector can also help you. It supports the notion of processing data, and this allows you to aggregate or filter or perform other operations on the telemetry data. And honestly, my recommendation would be, in most cases, let the OTel instrumentation, whether it's manual or automatic, let it send all the data to the collector. And if you want to do any processing, if you want to reduce any over-instrumentation, do it in the collector layer. That's usually a lot easier. So here's a high-level architecture diagram of the collector. It's basically a pipeline architecture. So you can see two different types of pipelines being defined, one with the orange line in the background and one with the green line. Basically, it's very customizable depending on your needs, and it gives you full control of your data. Now, how it does it is through a variety of different components that I'll walk through next. The 5 major components of the collector are receivers, how you get data into the collector. This can be either push or pull based. What do I mean? Well, trace spans are usually pushed from the application to the collector. But in the case of metrics, let's say you're using Prometheus, it's more common for the collector to scrape the application and get the metrics and pull them in. So push and pull are both support from a receiver perspective. Then you have processors, what you do with the data after you've collected it. As I mentioned, aggregating, filtering, things to that extent. Exporters, how you get the data out of the collector, because the end state is not actually the collector. In fact, this is an interesting distinction for the OpenTelemetry project. While it provides an open standard and it supports all the telemetry data, it does not provide an observability backend. Instead, it supports a wide range of open source and commercial observability platforms to send your data to. So processing is just before you're getting it to its final destination. Exporters are how you get it to that final destination. The 2 final ones are extensions. These are usually things outside of the data processing pipeline. For example, health checks would be a good example. Authentication would be another one. And then connectors are a little bit unique in that they are both a receiver and an exporter in one. They are basically meant for reprocessing data in the collector. I'm not going to talk as much about those today, but I have lots of talks on the OpenTelemetry collector. If you're interested, there'll be a link at the end, and you can take a look at those. But processors, this is where you can address many things, including over-instrumentation, and I want to provide a couple quick examples of what that would look like. The collector is configured via YAML, and so here's 3 very quick examples for you. One actually drops certain spans based on the instrumentation name. The second one drops specific metrics based on a metric name, and you can notice that globbing is occurring here, so you see the wildcard. This can be, so you don't have to specify every single name that you care about. You can get rid of a large range of them all at once. And the third is for removing metadata, or key value pairs. That can also be an over-instrumentation. While metadata is important because it helps with problem isolation, telling you if it's infrastructure or application related, there may be certain pieces of metadata that you don't need and you want to remove, and you can see an example here of how to remove them. Now, please note this is not a full example of a collector YAML. You actually need to specify receivers and exporters. You have to define a pipeline. I just want to show you briefly what the processor YAML configuration might look like to help deal with over-instrumentation. Third one for telemetry data would be inconsistent naming conventions. So going back to metadata, it's actually really, really important when it comes to telemetry. Just collecting a metric, some sort of number or counter, is great, but you really need to enrich it. Where is it in the environment? What's the service version number? Tell me more about it, basically. Maybe there's even business context there. And if you don't standardize the names that you're using for metadata, you're also going to have a bad time. So let me give you an example. There's two kind of big ones from the OpenTelemetry project. One, OpenTelemetry supports this notion of semantic conventions. It's just a fancy word for a name, a standardized name for a piece of metadata. And so I've shown a few examples here, HTTP, database, messaging, functions as a service. So for example, if you're using the OpenTelemetry instrumentation and you call out to an HTTP service, it's going to have attributes such as http.method and http.statuscode, regardless of the language that you're using. Now, if you don't have semantic conventions and you're in, say, a polyglot environment and you have different service owners instrumenting the app, they may call it different things. Maybe there's no underscore between status and code. Maybe the C is capitalized in code. Like, there's a whole bunch of different ways that you can name things, and I know if you're an engineer in the room, you probably understand there's certain ways you like to see things named. Well, you have to make sure this is consistent across your entire environment. Otherwise, it's really hard to achieve observability. OpenTelemetry provides this through the notion of semantic conventions, and this is something that you should look at adopting as well. Now, there may be conventions that you need that are business specific to you. They're outside of OpenTelemetry or outside of telemetry data. You should follow a similar naming standard. So for example, let's say, I work at Splunk, so com.splunk.name your key value pair. Now I know everything that starts with com.splunk is related to my business logic and my metadata. I can then standardize that across my company and make sure that people adopt it. OTel has a similar convention. You can do something similar as well. But standardization is going to be very key. And you can do some cool things with standardization. So let's say I have an application that's instrumented with OpenTelemetry, and it's calling out to a database that's not instrumented. Maybe it's a cloud provider database. Maybe it's some third-party database that you can't get instrumented. Well, if you're using OTel instrumentation with the semantic conventions, you can actually infer observability for that database, even though it's not instrumented. Because every one of your OTel instrumented apps calling that database, you'll be able to get all of the observability data for it. It's not perfect. If some other service is calling that database, you won't have that visibility, but it's way better than nothing, and having this standard across the environment is very helpful. Then you have resource information. This is usually infrastructure related, so what EC2 host am I on, which Docker container am I on, which Kubernetes pod am I on. This can actually help you do problem isolation very, very quickly. So going back to the currency example you saw in the service map, what if 100% of the errors are coming from one particular pod? Well, now I can go quarantine that pod, go spin up another one, and go figure out why that pod's having issues. That's the power of semantic conventions. All right, so two more topics to talk about. One is observability platform pitfalls or antipatterns, and then we'll talk about some cultural things. So when it comes to the observability platform, probably the biggest antipattern, and one of the reasons why OpenTelemetry, I believe, is so popular these days, is vendor lock-in. What do I mean by vendor lock-in? It means it's very hard to switch from one vendor to another. Well, why would you care if you're getting value out of that vendor? Well, you have to work with them. Cost could increase. Cost could be a factor. Security compliance restrictions could come in. Maybe a new leadership comes in and they want to switch the observability vendor. There's a laundry list of reasons why vendor lock-in can be a problem. And prior to projects like OpenTelemetry, you would actually have to take the vendor instrumentation and data collection aspects and install it in your environment. And if you wanted to switch vendors, you'd have to remove all of that and add another vendor's instrumentation and data collection. That's a heavy lift with almost no value to you as an end user, right? So really you want to instrument and collect data once, and then you don't really care where you send that data to, but you're already going to get the value out of it. That's what OpenTelemetry provides. If you adopt OpenTelemetry end-to-end, you should be able to switch vendors very, very easily as long as they support the OpenTelemetry standard, and most observability platforms today do. So that's why you should look at that aspect. Now, to be fair, OpenTelemetry does not solve all the vendor lock-in problems. Even if you are able to switch instrumentation and data collection easily, there are still like the alerts or the dashboards or even the APIs, maybe the Terraform and automation that you've added with the observability platform that you're leveraging. That's a lot harder to move. There isn't really an open standard for that today, or one that is blanketly used by multiple vendors in the community. But with things like AI, I think this is going to become easier over time because there are APIs to this, there are kind of schemas that you can follow, and AI, I think, is going to be able to help with some of this porting activity in the future, so you should be looking out for that to make it easier as well. Now, in the case of OpenTelemetry, there's actually this notion of distributions that I wanted to talk about, because this also helps from a vendor lock-in perspective. I'm going to talk about it from the collector perspective, but it's also applicable to instrumentation libraries as well. So the OpenTelemetry collector offers 4 different distribution models. Core, this is just the OpenTelemetry components. Contrib, this would include other open source aspects, commercially available aspects, and maybe things like the attributes processor or the filter processor I was showing you earlier. Kubernetes, which is all the components you need to observe within a Kubernetes environment. And then custom. There's actually a tool called OCB, which allows you to pre-package any way you want. Most people will probably start with the Contrib version because it has everything, but eventually you might want to rip some of the pieces out because you haven't tested it, you don't want to support it in your environment, maybe you have security concerns about it. So most enterprise production environments will eventually leverage OCB and probably make a custom build. These distributions are great because you're just picking and choosing the components that you care about. Now, vendors also offer distributions. Most vendors do. Now, using a vendor distribution is fine as long as you can take that YAML configuration and apply it to another OTel, say, distribution, and it should work. If that's not the case, then you have vendor lock-in, right? So maybe there's something vendor-specific in the YAML config, you remove that line. But in general, it should fully support everything in the upstream community. Usually, vendor distributions are just wrapping OpenTelemetry to make it easier to use, and maybe to fix some bugs that are not been supported in upstream yet and haven't been merged in. So it's kind of ease of enterprise readiness at the end of the day. But distributions are very powerful and help with vendor lock-in. Another anti-pattern would be tool sprawl. This would be using multiple observability tools. So how many people have more than one observability platform in their environment today? Oh, less hands than I thought. All right, only about a quarter of the room. This is also common, especially in large enterprises where maybe you have acquisitions, you bought other companies and they're using other observability tools. Maybe one team is using a certain metrics store while a different team's using another one. Or I've also seen like you have a different tracing observability platform from your metric, from your logs. This is an anti-pattern because you don't have full observability. How are you going to get context and correlation? How are you going to launch between multiple different tools in your environment? How do you train people on like all the query languages that you need, the alerting capabilities, the dashboarding? It's really, really hard. So the more that you can consolidate, the better. But at the very least, you need context and correlation across these tools. OpenTelemetry can help because it provides that open standard and it actually stitches traces, metrics, and logs together. So you can go from a metric to its trace or from a trace to its associated logs. But you need to make sure that your observability platforms actually support that capability, or you need to consolidate onto an observability platform that does it for you. But it's really not about traces, metrics, and logs. It's about the visibility into your system and being able to answer the right questions. Tool sprawl can actually prevent that. And then finally, we have underestimating scalability requirements. Scale is a real problem. You're probably growing the number of services that you have. Maybe you have more microservices. Maybe you're moving from a monolith to microservices. Maybe your company's growing and you're deploying new regions or realms. The net result is that data is exponentially growing. This means your costs for observability platforms is probably exponentially growing. Maybe the latency in your observability platform is growing, and performance could be going down. So you need to make sure that you can address this scale. I already mentioned that things like the OpenTelemetry collector can help with it. You have full control, but you have to do that analysis yourself. I'm hoping that there's going to be a lot more edge capabilities coming out and even AI capabilities that will help kind of control the data in your environment. But today, this is a pretty difficult problem. Finally, we have company culture. And you can have a bunch of anti-patterns here as well. But the two main ones I'm going to call out are silos and lack of collaboration, as well as lack of ownership and accountability. These things will really impede your observability practices. So I would encourage you to look at centralizing or having a center of excellence for observability in your company. Think about having like a platform engineering team that kind of owns some of these aspects. Make sure that you're defining best practices, such as the semantic conventions for the metadata that you care about. And make sure you're iterating continuously in your environment, as following some of the SaaS best practices, such as clear service ownership or blameless postmortems. Now, I would still encourage you to take a look at the OpenTelemetry community, because I think you can actually leverage some of these aspects as well. They have a governance committee. They have a technical steering committee. They have special interest groups. This notion of maintainers, approvers, and triagers. You may call them different things in your environment, but you can probably leverage some of these concepts in your company to improve your observability best practices as well. So wrapping up here again, there's a bunch of great information about OpenTelemetry available out there. I provided some links on the OpenTelemetry IO site, including the community, docs, and demo environments. I also have a wide variety of talks on OpenTelemetry, so if you're interested in that, you can take a look as well. And I think with that, we are at time, so thank you so much. I'll try to answer questions, and if not, I'll be in the hallway after the talk. Thank you so much. Any quick question in the room? Yeah? So you're saying for scalability of the OTel collector, in the case of Kubernetes, you only have one config, so the config's the same on all the collector instances. That does not have to be the case. So it supports like config maps. You can do it in your, what's it called, namespaces. You can have different deployment models for service, like you can do like a daemon set for agent mode, and you can have a service for your aggregation or gateway mode. So all of that can have different YAML configuration files. So you should be able to scale each part independently if you want. Yeah, so you're saying if you're scraping an endpoint and you only have one configuration, how do you make sure that it can scale to support? So in the case of Prometheus, I can link you to how they do it. It's not pod labels, I'm forgetting the name. But there is a way to restrict the devices that you're scraping to allow you to scale it out. So this is supported in OTel today. Come touch base with me in the hallway and I'll show you where it is so you can figure out how to do it. Great. I think we're at time, so I'll move to the hallway and I'm happy to kind of answer questions. I want to make sure there's time for the next person to kind of, do I have time for one more? We're good. Great. All right. I'll meet you in the hallway. Thank you, everyone.